Here we're going to take a look at doing coordinate proofs using triangles. So what I want to be able to do is I want to be able to prove the distance from point P at x sub 1 comma y sub 1 to point Q at x sub 2 comma y sub 2. But what I find is students often find it most comfortable if we can use numbers. So to get between numbers and the actual proof, I've set it up with generic letters A, B, C, and D as coordinate locations. Instead of x1, y1, I use A and B. Instead of A and B, in the numbers, I use 1 and 2. So we're going to go through it a step, then a step, then a step, so that we can see that what we're doing is not such a big deal. So what I need to do is I need to find a point to build a triangle. And I'm going to build a right triangle to make my life easy. So what I'm going to do is I'm going to go ahead and make a new point here, and I'm going to call this point Z. And I'm going to do the same in all of mine, as this is the method I'm going to go about doing this. Now Z, if it is a right triangle, I can come over and I can see that my y coordinate here is a 2. My x coordinate is a 5. This is going to give me that right triangle. More specifically, what I see is I get to take my y coordinate from P, my x coordinate from Q. So Z gets to be located at C, comma, A, and Z over here gets to be located at x sub 2, comma, y sub 1. And all we're doing is establishing a right triangle where we're trying to find now the hypotenuse. So at this point, having these triangles, what I'm able to do is I'm able to go ahead and figure out that our Pythagorean theorem says for a right triangle, then a squared plus b squared equals c squared, or the sum of the squares of the sides are equal to the square of the hypotenuse. So really simple. PZ, the distance here, is going to go from 1 to 5, or I'm actually going to think of it as 5 minus 1. So I see 5 minus 1, or 4. But here I have only letters. So I'm going to say PZ is equal to C minus A. And I'm going to say here that PZ is equal to x sub 2 minus x sub 1. All I'm doing is establishing some side lengths. I see that, let's put my PZ in there. I see that QZ is equal to 6 minus 2, or 4. So that means that QZ here is D minus B. And I'm really just substituting letters over and over again. So I can say that QZ is equal to Y2 minus Y1. Now again, knowing that the Pythagorean theorem says that A squared, we're going to say that PZ squared plus QZ squared is equal to PQ. So we're setting up with all of the same things. PZ squared is equal to QZ squared, plus QZ squared is equal to PQ squared. And at this point, what I'm going to do is I'm just going to simply run some substitutions. I see that PZ is equal to 4, so that's a 4 squared, and QZ is equal to 4 is equal to PQ squared. So substituting again here, I get that c minus a squared plus d minus b squared is equal to pq squared. In very generic terms, x sub 2 minus x sub 1 squared plus y sub 2 minus y sub 1 squared is equal to pq squared. So now what I've got is the distance is equal to the square of each side, and I've set it up each way. Now at this point, I'm not even really worried about calculating. I'm going to take the square root of both sides. This is going to mean that the square root of 4 squared plus 4 squared is equal to the length of pq. Or the square root of c minus a squared plus d minus b squared is equal to pq. Again, just square rooting both sides. So that same square root of both sides is going to give me the square root of x sub 2 minus x sub 1 squared plus y sub 2 minus y sub 1. Oh my goodness, I am having trouble writing today. Squared is equal to the length of pq. So if I was to take the length of PQ and talk about a generic triangle, if I said what I'm actually talking about is the distance from P to Q, so I could say PQ is actually talking about a distance D. So the square root of x sub 2 minus x sub 1 squared plus y sub 2 minus y sub 1 squared is equal to D. And we get our distance formula. What I suggest students to do to be able to get a grasp of writing some of this stuff initially is give themselves 3. If this is your actual problem, back it up a little bit, give yourself totally different letters to work with, and then back it up a little bit more and give yourself numbers. And it doesn't matter if your numbers work nicely. In fact, these numbers don't work nicely. This is the square root of 32. Is equal to PQ. Well, 32 is 4 times 8. So 4 times 4 times 2. So I get this is 4 square root of 2 is my distance from P to Q. Not a neat answer. But it's going to work in every single case, and that's one of the reasons that I'll just hold off on actually calculating until the very end. Remember, math rocks with a capital M.